Hello friends, today we are going to discuss a little bit about the pulley string system and problems related to it. So the problem in front of us is two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless. Now we have to calculate the acceleration of the system in terms of acceleration due to gravity. It is a very simple question. But we are not here to solve questions only, but we are here to learn physics, the actual concepts from basic to intermediate level to advanced level. So I would be listing down the concepts that we are going to learn today. First is tension and compression force. Tension and compression. Second concept we are going to discuss in the question, often you would see in all the pulleys and string system questions, you would see inextensible string, and sometimes it would say massless string. So these things would always be given, or would be given in most of the cases. String would be considered to be massless and inextensible. Why? What is the significance? You would learn later. Pulleys. The pulleys would most often be described as frictionless and massless. Even in this question they say the pulley is frictionless. So often you would see pulley is frictionless and massless. Why it is so? We would also learn it. Then we would briefly discuss Newton's 3 laws of motion. All of us know, because this question is very simple. So its solution is going to take only 1 minute. So instead of solving the question, we would better learn the basic concepts in detail. This would add to our knowledge and understanding. Newton's 3 laws, and that would also help you review the concepts. Most of you would already be knowing these concepts. So this is all. So let us start with tension and compression. What is tension? Tension is a pulling force. When an object is exerted, two forces in opposite direction and away from each other, then they create tension inside the material of the body. Similarly, when an object is applied, two opposite forces towards each other, not away from each other, they create compression inside the material of the object. In the first case they create tension, and in the second case they create compression. We cannot create compression in a string because it is flexible, so we can create compression only in rigid bodies. But tension we can create in all flexible as well as rigid bodies. There is a common misconception. People feel that only flexible bodies like strings or flexible wires, only they can be subjected to tension. No. All objects, they may be as rigid as possible, they can be subjected to tension. For example, in all the buildings and structures you have seen, there is a reinforcement steel. There is a steel reinforcement inside concrete. Why is it provided? In most of the cases it is provided to take tension, because concrete is weak in tension. Also, this reinforcement takes compression as well. It is not so that it only takes tension, but it can be provided to take tension as well as compression. So we discussed tension and compression. So let us take a typical example of a string. Suppose this is a string. These are the two ends. We pull this string from this side. We cannot create tension by holding the string at one end only. We have to hold it at both the ends. So we exert some force on the other. So what happens? We put a force T. We apply a force T on the string. So string would also apply a force T on us. Similarly, We apply a force T on the other end of the string. We pull the string outward. So the string would be pulling us with the same and equal force as per Newton's third law. So the T which is shown inside the string is not the force on the string, but it shows the direction of the force applied by the string on this point, that is on the object which is providing tension to it. So if you consider this point of the string, you can see the net force on this point is 0. This point is being pulled by the string to this side T with a T force, and the external object is also applying a force of T, so net force is T, 0. Similarly, you take any small portion of the string. This is a small portion. So the tension would be acting at every point of the string in opposite direction, like this. That is why this small point or a small portion of the string is in equilibrium. It is not moving. If there was net force, it would start moving. So tension is a force which is distributed at every part, every point of the string throughout its length along the axis. So it is in both the directions. It's very simple. Now we would discuss why we always say, or most often we say, the string is massless and inextensible. Massless simplifies our problem. If it is massless, so we can ignore the kinetic energy and potential energy of the string, because kinetic energy is half mv square, potential energy is mgh, mass being 0, you can ignore the energies associated with the string. So it simplifies our problem. We can only focus on blocks. And also pulleys are often massless, so you can also ignore the kinetic energy or work done to rotate pulleys because they are massless. So m is 0. So you only focus on what happens to the actual weight. You ignore the string and the pulleys. The pulleys are frictionless. This is very important. When the pulley is frictionless, in a typical pulley string arrangement, there is a mass m1 kg. On the other hand, there is another mass m2. So this mass would be applying some tension on the string, and as I told you, the string would apply some tension on the object m1. This arrow indicates not the force on the string, but it shows the force applied by the string on this object upwards. Similarly, force applied or tension force applied, a force applied by the string on this object. Tension force on the string would be downwards, opposite to this. So this would also be T. So if the pulleys are frictionless, the tension on one string would be same at every point. So this is T, this would be T, at this point tension would be T, tension would be T, tension would be T, and after passing over pulley, the tension would still be T, because the pulley is frictionless. If the pulley was not frictionless, the tension on both sides of the pulley would be different for the same string. This would become T1, this one become T2. So this is very important. In most of the question, we would be given the pulleys are frictionless. So we would assume same tension. Now, we would briefly discuss Newton's 3 laws of motion, just to recall, just to review it. First law of motion, which is also called law of inertia. It says a body will continue to be in its original state, whether at rest or moving with a constant velocity, unless it is acted upon by a net force. So in the absence of a net external force, the body will maintain its previous state of rest or motion with constant velocity. Simple. So it means if force is not there, velocity would not change. So from here we can go to the second law. It means if force is there, velocity would change. If velocity changes, we call it acceleration. So first law defines the effect of force. That force is something which changes the state of rest or state of motion of a body. Second law quantifies the force. It tells us how much force is required. It tells you, the first law tells you the effect of the force, the qualitative nature of the force, that it is a physical quantity that can change the state of rest or motion. And second law helps you measure the force, how much force you need to change the state of rest or to change the state of motion. Second law is often read in two forms. The rate of change of linear momentum of an object is directly proportional to the force applied. So, rate of change of linear momentum. Linear momentum is mv, right? mv is the linear momentum of any object, mass times velocity. So change of linear momentum would be delta mv, right? Rate of change of linear momentum will be delta mv upon delta t. Rate for any object is means per unit of time, so we have to divide by time difference. Rate of change of linear momentum is directly proportional to the force. This is second law of motion. M is always constant, it never changes, so M would be same. So delta mv means final momentum minus initial momentum. Final momentum would be mv2, initial momentum would be mv1. Delta t is proportional to F. We take M common, so this becomes v2 minus v1 upon delta t, proportional to force. v2 minus v1 is change in velocity. Delta t is time difference. Change in velocity per unit time is called acceleration. Acceleration is nothing but rate of change of velocity, and v2 minus v1 upon delta t is rate of change of velocity. So this is by definition acceleration. ma is proportional to F. When we remove the sign of proportionality, we introduce a constant k and we make it F. And by practical demonstration we can find out the value of k, which comes out to be 1 in this case. So we have F is equal to ma. So Newton's second law is often described in terms of F is equal to ma. Force required to produce acceleration in a body is directly proportional to the mass of the body and is directly proportional to the acceleration required. You need more force to produce more acceleration. You need more force to produce same amount of acceleration if the mass increases. So bigger bodies need more force for a particular acceleration, smaller bodies require less force. Similarly, when the body size is same, more force is required for more acceleration. Again, second law of motion can be read in these two forms. Rate of change of linear momentum is directly proportional to the force, or we can say force is directly proportional to the mass of the object and the acceleration of the object. Third law. Newton's third law is often called action-reaction, law of action and reaction. So it says force cannot be applied in isolation. When you apply a force, you also feel the force. It is not like you apply a force and you feel nothing. So every force has a reaction. So if in simple forms, if a body A applies some force on body B, then body B applies equal and opposite force on body A. This is by definition Newton's third law. So we have discussed all these three laws. The basics. Now let us solve the question in terms of Newton's second law. In this problem, this is 4 kg mass, this is 6 kg mass. When you release this system, you know what happens? The heavier mass would start going down and the lighter mass would start going up. It would move with some acceleration downwards. The same acceleration would be on this block, but it would be upwards. Why same acceleration? Because there would be same displacement, same velocity, because they are connected by the same string and the string is inextensible. So same is velocity, same acceleration, only the direction would be different. Magnitude would be the same. So let us draw the free body diagram for each block. What are the forces acting on this 4 kg block? So this is 4 kg block. First is its weight. Earth is pulling it down with 4g, mg, 4 times g. Mg would be the weight of the object. Now, the string is pulling it upwards. with a force equal to tension in the string. We assume the tension produced by this block on the string would be T, so string would also be pulling the block with the same tension. If the block is pulling string downwards with a force T, string would be pulling the block upward with a force T, as per Newton's third law. So in this block, there would be an upward force T. T would be more than the weight. That is why this block is moving upwards and with some acceleration. So we know F is equal to ma. Force is equal to mass times acceleration, and this F is net force, not individual force. It is the net force, and this acceleration is the net acceleration. So net force in upward direction would be T minus 4g. Mass of the block is 4 kg. We assume it is moving with an acceleration of a. Upwards it is moving with an acceleration of a, and therefore this would also move with an acceleration of a, but downwards, because they are connected by the same inextensible string. T minus 4g equal to 4a is the first equation. Similarly, we draw the free body diagram for the second block, 6 kg block. There would be a force acting downwards, which is the weight of the object, which is 6g. mg is the weight. And again, this string would be pulling this block with the same force. Tension would be same. Why? Because pulleys are frictionless. So upwards there would be a force of T. This block is moving downwards, means this 6g force is more than tension. So what we can write is 6g minus T is equal to, so F is equal to ma formula. Force, net force would be 6g minus T. Mass is 6 and net acceleration would be a, downwards. This is equation number 2. We simply add equation number 1 and equation 2. So we get T minus 4g plus 6g minus T is equal to 4a plus 6a. T cancels T. 6g minus 4g is 2g. This becomes 10a. So a becomes g by 5. This is the answer, probably option number B. Very simple question. So question is very simple, but the concepts we have to learn first. And this is what our efforts are always for every video lesson. So quickly reviewing, we have learned tension and compression. When two forces, when a body is subjected to opposite forces moving away from each other, the material of the body undergoes tension. There is some tension created in the, which is tension is the pulling force. It has the tendency to provide extension in the body. When two forces towards each other are acting in a body, they produce compression inside the body. Compression has a tendency to compress the object, to reduce its volume, or to produce compressive stresses. Then we discussed inextensible string and massless string. Inextensible string means the string would not extend. So the force, the work done by tension in the string would be zero because it is not extending. So there is no displacement in individual particles with respect to the rope. So work done by tension inside a string would be zero. And also the tension on both the sides of the pulley would be same, or the acceleration or velocity of every particle of the string would be the same in terms of magnitude. Then we discussed the pulley is frictionless. It means the tension on both sides of the string would be same. If there was friction in the pulley, the tension would be different, T1 and T2. I also explained that what we show by T is, this is the force exerted by a string on this block. This would be upward. The block would pull the string downwards. So block would provide tension in the string by pulling it downwards. So the string would pull the block upwards as a reaction. Similarly, the string would pull the block upward. Right? So T, M1, M2. Then we discussed 3 laws of motions. The first one is law of inertia. If a body is in a state of rest, it would continue to be in a state of rest. If a body is moving with constant velocity, it would continue to move with that constant velocity until there is no net force. Right? Second law says how much force is required to produce acceleration. So by definition, rate of change of linear momentum of an object is directly proportional to the force required. And by this we can derive the formula F is equal to ma. So Newton's second law is F is equal to ma. Force required to produce in an acceleration, force required, or we can say force is directly proportional to the mass of the object and directly proportional to the acceleration being produced on the object. F is net force, A is net acceleration. For solving this problem, we drew free body diagram for 4 kg mass. 4g, mg would be the weight acting downwards. A string would be applying same force as its tension on the block. Since the block is moving upwards with an acceleration a and the other block is moving downwards with an acceleration of a, same acceleration in magnitude because these two are connected by the same string. So t would be more than 4g in this case. So t minus 4g would be equal to ma, 4 times acceleration. We have to calculate a. Second, we drew free body diagram for 6 kg block. Net force would be higher downside because it is moving downwards. So 6g would be the weight. 6g minus t would be equal to m times acceleration. We make second equation. We simply add first and 2 in such a way because t is plus here, t is minus here. So we simply add. We have to remove t. So t cancel out. We are left with a and g and we find the relationship between a and g. A is equal to g by 5. Thank you.